All right, section or lecture 3.1 for section 3.1. We're looking at quadratic functions. Okay, so there are two different forms for quadratic functions. You have the general form, which is the one we normally use, and this is the one we use when we're working with the quadratic formula. So you can find your a, b, and c values easily. Now there's a different form, which is the standard form. Might kind of look a little bit like the standard forms for a circle. And notice the importance for this form is that we can pull out the vertex easily by taking the opposite of the value by x and then the k value. Okay, so both of these forms are important. The first one is important if you want to use the quadratic formula. The second one is important if you want to find the vertex easily. Okay, but we're going to take a look at the standard form. Okay, so the one thing to note when we're looking at parabolas or quadratic functions in terms of when the x value is being squared is there are two options. We have the parabola opening upwards or the parabola opening downwards. Okay, and some of the main features about parabolas are that you can have your x and your y-intercepts, as well as a thing called the vertex. Okay, the vertex is where the line of symmetry passes through in the middle for either of them. And that's where, for example, if I have a point here that is 2 units away, I know there exists a point exactly 2 units away on the opposite side. Okay, so that's where that line of symmetry comes in. Another important thing for parabolas has to do with the vertexes. Okay, so this point here, is there a point that has a smaller y value than this one? No, that is the smallest y value possible. Can I find the biggest y value possible? Well, you might say that this is the biggest y value possible, but I could say, but remember, this still extends upward to infinity. Okay, so there is actually no biggest y value, but for the opening upwards parabola, there is the smallest y value, and we call this a minimum. So if a parabola opens upwards, it has a minimum value. Now the opposite happens when we have a parabola opening downwards. Do we have a minimum value? Well, you might say that that's the minimum value, but I could say, how about that point? And then you could go and say, well, maybe this point. And we could go on and on for infinity. So there is no minimum value for parabola that opens downwards. However, there is a maximum value at the vertex, and the biggest y value. Okay, so if a parabola opens down, we have a maximum. If a parabola opens up, we have a minimum. All right. So let's take a look at the first example. We're given f of x equals x squared minus 2x plus 2. And we're told to write it in standard form. Okay, so this is going to be very similar to how we get circles from the general form to standard form. We're going to be using completing the square. Yes, I know you love to hear that. Okay, so let's use completing the square. This one's going to be slightly different. Okay, there's a wee bit of a trick to it, so keep those eyes open. All right, so I want to complete the square. So same idea what happens. I'm going to group my x values together and leave that number that doesn't have x out on the side. And my goal is to find that perfect number that would make this into a perfect square. Okay, so some binomial going on here. So to find that perfect number, remember we take the b value, divide it by 2, and square it, which is going to end up being 1. So we're going to add 1 to this equation, but we have just changed the problem. So normally, we would add 1 to the other side, but I want to leave f of x by itself. I don't want to be adding 1 to this side. So to be very sneaky, okay, sneaky mathematic trick here, if I add 1, and I don't want to change my problem, I could just subtract 1. Because adding 1 and subtracting 1, you actually just undid what you did. We haven't changed the problem. We've sneakily done nothing, in a sense. Okay? So we added 1, and to balance that out, we're subtracting 1. Okay? So sneaky trick there. All right, and then when we factor this out, we get the perfect square binomial x minus 1 squared, and then 2 minus 1 is going to give me plus 1. So here we go, my parabola in standard form. Okay, with completing the square with a slight modification when we add our perfect number. So finding the vertex and the intercepts. Well, vertex, since it's in standard form, I can handily-dandly find my vertex, which is going to be the opposite of my h value and my k. So that's going to be 1, 1. Right, and then the intercepts. Well, let's go ahead and do the x-intercept, which means I set y to 0. So 0 equals x squared minus 2x plus 2. That doesn't factor, so I'm going to go ahead and use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. That's going to be 2 plus or minus square root of 4 minus 8. Oh, 2. All right, see what's going on in here. That's going to be a negative number under my radical, which means it's not a real number. So we do not have any x-intercepts. So remember, when you're telling me if you have an x-intercept, please do not write x-intercept 0. Because to me, that means you're telling me your x-intercept is the number 0. So if you want to tell me that there are no x-intercepts, just write none. Okay? That way I clearly know that you have no x-intercepts. All right, let's go ahead and find the y-intercepts, or intercept, which means we're going to set x to 0 and solve. All right, setting x to 0. Oops, this is, whoa. Okay, remember just plugging in 0 for our x values. So y is going to equal, that goes to 0, that goes to 0. And we're left with negative 2. So my y-intercept, plus 2, not positive 2. Sorry, I wrote that down wrong. It's supposed to be plus 2. All right. Let's go ahead and graph this now. Step 3, sketch the graph. Okay, so my vertex is going to be 1, 1. So 1, 2, 3, 4, 5. So 1, 1. And my y-intercept is 0, 2. 0, 2. Okay, and I know this is my vertex. I'll go ahead and label it with a V. Actually, you know what? I want to move that 1, 1 out of the way. Labeling my vertex with a V, so you are indicating to me that you know that's the vertex. And then I'm going to go ahead and find one more point. So using that line of symmetry that passes through my vertex, I can identify that there's a point opposite of this one, which will be right here at 2, 2. Okay, and there we go, sketching our graph. Ooh, that's a little ugly, but it'll do. All right, let's see. Is there a maximum or minimum value, and what is it? Well, since it's opening up, that means it has a minimum. So we have a minimum value at what point? 1, 1. So the minimum value at 1, 1. Okay, and the minimum value is actually talking about your y. So the way you could also write it is a minimum value of 1. Okay, so it's at the point 1, 1, or you can say the minimum value is 1, the y value. All right, let's find the domain and range. Okay, so the domain, that's all the x values I use. Well, looking at this, I'm going to continually open up to that direction, the left, and open up to the right, which means I will slowly use all of the x values. So the domain of f is going to be negative infinity to positive infinity. Now, see if you can find the range. Try pause the video and see if you can find the range. Well, the range, we start at our lowest y value, which is 1, and then we go on till our highest y value, which is actually going to be, well, these go on forever, so it's actually going to be positive infinity. So we start at 1, and we go to positive infinity. All right, not too bad. One more example, and then that is it for section 3.1. Okay, so here we are. We're given a function, negative 3x squared plus 6x minus 2, and we're told to write it in standard form. Okay, so this one's going to have a wee bit more of a trick than last time, because last time we didn't have a number in front of our x, so we didn't have to worry about that. This time we do have a number in front of our x squared. So that is a wee bit of a concern, but don't worry, we know how to handle those. If not, I'll show you how. All right, so number 1, write in standard form. So once again, as I mentioned, our concern is kind of that negative 3 in front of the x squared. So what I want to do, I'm going to group my x's, as usual. But then I want to get my x squared by itself. So I'm going to factor out that negative 3. Okay, so factoring out that negative 3, I'll get x squared minus 2x minus 2. Okay, so once I factored out that negative 3, now I can go ahead and try and complete the perfect square trinomial here. Okay, to do that, once again, remember, to find that perfect number, we take our b value and divide it by 2 and square it, which gives me 1. So I'm going to add 1 here. But now I have to be careful. When I'm balancing out my equation, ask yourself this: did I really just add 1 to this problem? Well, if I was to FOIL this back out, that'd be negative 3 times x squared, so negative 3x squared. Negative 3 times negative 2x, which would give me the positive 6x. And then that would be negative 3 times 1. So let me put that on a sticky note. So that would be, if I multiplied the negative 3 out, that would be negative 3x squared plus 6x minus 3. So, actually, when I add the 1 in here, what I have really done is I have added a negative 3 to my problem. So be careful when we're working with that negative 3 on the outside. So how do I balance having just subtracted 3 from my problem? Well, to balance that out, we'd add 3. Because negative 3 and positive 3, those would cancel each other out. And then I would just be left with my original equation of 6x minus 2. Okay, so what I'm going to do to balance out the fact that I technically added that hidden negative 3 there, I will add 3. Okay. You can go ahead and FOIL that out to make sure we do end up with the original equation. Okay, once I've done that, so negative 3, and then this factors into the perfect square binomial of x minus 1 squared. And then we're left with, well, negative 2 plus 3 is positive 1. And there we go, not worse for wear, f of x. Okay, so there's that added extra step when we have to factor out the number by the x squared. Okay, so keep a weather eye out for that. Now let's find the vertex. Okay, nice thing, this is in vertex form. So I can go ahead and identify that, which is going to be 1, 1. And let's go ahead and find our x-intercepts. Now this time, I'm going to use this function here to find my x-intercept. So setting y to 0, let's solve for x. Well, this looks like it might be completing the square, so let's go ahead and minus 1 from both sides. Getting x by itself, we'll go ahead and divide negative 3 from both sides. So we're left with 1 over 3 equals x minus 1 squared. We can complete the square here. So square rooting both sides. Remember the plus or minus, very important. And then we have plus or minus the square root of 1 over 3 equals x minus 1. Whew, almost there. Let's get x by itself by adding 1 to both sides. And we have, I'm going to flip this, x equals 1 plus or minus the square root of 1 over 3. I think we're going to need to rationalize this baby. Okay. So that's going to be x equals 1 plus or minus, and then rationalizing this, we'd end up with the square root of 3 over 3. Okay, so rationalizing your answer. But what would that number actually be? Because for graphing, we want to have something, it's harder to figure out what the graph of square root of 1 over 3 is. So let's go ahead and figure out, oop, my battery just died in that calculator. Let me pull out my phone. All right, here we go. So, my wonderful cheap phone. Okay, so we are finding square root of 1 over 3. Ooh, gotta go into the other mode here. Okay. Square root of 1 minus 3, so that's going to be, let's see how this does it, I always forget. Nope, the other way. Square root of 1 divided by 3. All right, that is going to be 0.5, so a little more than half. Okay, let's just go with half. Okay, so let's go ahead and yeah, I'll just go ahead and call that half. Actually, let's go with 0.6 actually. So for graphing this, that's going to be 1 plus 0.6 and 1 minus 0.6. But for the actual values, it's going to be 1 plus the square root of 3 over 3, and the other one will be 0, 1 minus the square root of 3 over... Ooh, gosh, I just realized we're supposed to set y to 0, and I just wrote it that way. Sorry. X-intercept, it's going to be 1 plus square root of 3 over 3, comma 0, and 1 minus the square root of 3 over 3, comma 0. Okay, and graphing those, that's going to be, well, my vertex is 1, 1. And my x-intercept is going to be 1 plus 0.6, so it's going to be 1.6 about. And 1 minus that, so it's going to be about there. And then let's see what our y-intercept is. Okay, y-intercept, set x to 0. So it's going to be f of 0 is going to equal negative 3 times 0 squared plus 6 times 0 minus 2, which will equal 0 plus 0 minus 2 equals minus 2. Sorry, I guess you didn't see that going on up there. Those are my x-intercepts right up there. And then that's going to be minus 2. So 0 minus 2 right there. Okay, my y-intercept, and I can go ahead and sketch in my graph. I'll identify V as the vertex. Please write that on your papers as well. And let's see, do we have a minimum or maximum? Well, since it's opening downward, we have a maximum at the vertex. So we have a maximum of, and our y value at this time is 1. Or you could write it a maximum at the point 1, 1. Okay, 2 different ways to write it. And lastly, the domain and the range. Well, the domain, dome of f. Go ahead and try see if you can find these by yourself. Pause the video and check back in with me. Okay, the domain is going to be negative infinity to positive infinity. And the range is going to be from, well, the smallest possible number would be negative infinity up to the maximum number, which was 1. And we can include 1. All right, And that is it for 3.1. You have your written homework worth 10 points due at the end of the week. Please email me if you have any questions.